A big hi to all the students. Our today's topic of discussion is chemical kinetics. In general, we can say that chemical kinetics deals with the various chemical processes and their rates. It gives us important information about how a reaction takes place, at what rate does it take place, how is it influenced by various experimental conditions, what are the various transition states involved, and what is the mechanism of the reaction. We'll name today's session as Chemical Kinetics Part 1, in which we are going to discuss some basic terminology related to our topic, and also zero order, first order, and second order reactions. Then we'll continue our discussion in the next session as well, which we will name as Chemical Kinetics Part 2. So let's get started with Chemical Kinetics Part 1. So we can define chemical kinetics as the branch of chemistry which deals with the study of rates of chemical reactions, the factors affecting it, and the mechanism by which the reactions proceed. Due to this definition, chemical kinetics is also known as reaction kinetics. The first part of the definition of chemical kinetics says that it deals with the rates of chemical reactions. So for studying chemical kinetics, the first thing that we should be clear about is that what exactly is the rate of a reaction. We can define the rate of a chemical reaction as the change in the concentration of the reactants or the products per unit time. So mathematically, we can write that rate of a reaction is equal to change in concentration divided by the time period of change. So if we consider a general reaction in which two reactants A and B combine to form the product C, we can say that the rate of this reaction will be minus dA upon dt. That is the change in the concentration of this reactant with time. Or the rate will be equal to minus dB upon dt. That is the change in the concentration of the other reactant with time. Or rate will be equal to dC upon dt. That is the change in the concentration of C, that is the product with time. The negative signs at these two places, that is dA upon dt and dB upon dt, are negative because it means that the concentration of the reactants is decreasing with time because they are getting consumed, forming the product C. Whereas dC upon dt, that is the expression of rate in terms of C, is positive. That means the concentration of the product is increasing with time. So if we plot a graph between the concentration of the products and the reactants and the time, then we can see that the concentration of the reagents or the reactants, which is shown with orange line, decreases with time, whereas the concentration of the products, shown with the maroon line, increase with time. Now we express the rate of reaction as we can say, suppose dx upon dt, in which dx is the change in concentration and dt is the time period during which that change took place. Now the unit of concentration is moles per liter and that of time is seconds. So we can say that the unit of rate of reaction is moles per liter per second. In case of gaseous reactants, we express the concentration of the reactants in terms of partial pressure. So the unit is atmosphere per second. The rate of reaction is not constant except for zero order reactions. Very soon we are going to discuss zero order reactions and we'll see what is the case with them. Otherwise, it decreases as the reaction proceeds in the forward direction. Now, if you remember, the graph between the concentration and time was something like that. We plotted concentration on the y-axis and time on the x-axis. And the curve for the reactants was something like that. Now, if we want to calculate the rate of reaction at a particular time, suppose at this point, we can see, suppose this is time A and we need to calculate the rate of reaction at this time. We can see what is the corresponding point on this curve. We can draw a tangent and we can find the corresponding concentration at that time and calculate the rate of the reaction at that particular time. Then the rate of reaction is generally seen to increase with rise in temperature. Generally, it increases 2 to 3 times with every increase of 10 degrees centigrade in temperature. If we express the concentration of the reactants as a function of time, then that mathematical expression or that equation is known as integrated rate equation. So if we consider a general reaction in which A moles of the reactant A and B moles of the reactant B react to form C moles of the product C and D moles of the product D, then the average rate will be equal to minus 1 upon A delta A upon dt. Delta A will be the change in the concentration of A during the time period dt, or minus 1 upon B delta B upon dt, or 1 upon C delta C upon dt, or 1 upon D delta D upon dt. We can also calculate the instantaneous rate, which will be equal to minus A dA upon dt. dA will be the concentration of that reactant at that particular instant of time. It can also be equal to minus 1 upon B dB upon dt, or 1 upon C dC upon dt, or 1 upon D dd upon dt. Let's take an example. For a given reaction, A plus 3B gives 2C plus D. Which of the following statement is true? So before checking out these choices, let's first write the expression of instantaneous rate for this reaction. It will be equal to minus dA upon dt, which will be equal to minus 1 by 3 dB upon dt, which will be equal to plus 1 by 2 dC upon dt, and it will be equal to dd upon dt. Now let's take the first choice. The first choice says dA upon dt is equal to dC upon 2 dt. Now if we consider these two terms, then we can write minus dA upon dt is equal to 1 by 2 dC upon dt. Now this minus sign is missing in this expression, therefore A is incorrect. Let's come to the second choice. Minus 3 dB upon dt is equal to 2 dC upon dt. Now if we compare these two terms, we can say minus 1 by 3 dB upon dt is equal to 1 by 2 dC upon dt, or minus 2 dB upon dt is equal to 3 dC upon dt. Now it's minus 2 dB and not minus 3, and it's 3D and not 2D. So B is also incorrect. Now let's compare the terms for A and B for the third choice. Our equation says minus dA upon dt is equal to minus 1 by 3 dB upon dt. These minus signs will get cancelled, and if we multiply 3 to dA upon dt, we get 3 dA upon dt is equal to dB upon dt. This matches this third choice, that is C, so C is correct. Let's check for choice D as well. If we compare the terms for B and C, we can write minus 1 by 3 dB upon dt is equal to 1 by 2 dC upon dt. This 1 by 3 is missing in this choice, therefore D is also incorrect. So our correct choice is C. There are various important factors which influence the rate of a chemical reaction. The first is the nature of reactants. The rate of reaction depends greatly on what kind of chemical bonding is found in the reactants, how much energy is required to break those bonds. Generally, the reactants which have covalent bonding tend to react slowly, whereas those reactions which involve ions or primarily involve the transfer of electrons take place rapidly. The second important factor is the physical state of the reactants. The reactants which are in solution form or in gaseous form tend to react more rapidly than the reactants which are solids. Also, those reactants which are in the same phase react rapidly as compared to those reactants which are in different phase. Because when the reactants are in different phase, the reaction is limited to the interface of those phases, which slows down the reaction rate. The third factor is the concentration of the reactants. By increasing the concentration of the reactants, the probability of the collision between the reactant molecules increases and therefore the rate of reaction increases. In case of gaseous reactants, the increase in the pressure of the reactants has the same effect. That is, it causes increase in the rate of reaction. Next important factor is the surface area of reactants. The rate of reaction is directly proportional to the exposed area of the reactants. Let's take a simple example. If we try to burn a log of wood with a matchstick, it will not be possible, I suppose. But if we axe the log into small chips and then try to burn it with a matchstick, we will have greater probability of success. That is because the exposed area of the reactant, that is the wood, increases many folds when we convert it into small pieces, rather than have a single large piece of wood. The next important factor is the temperature. When we increase the temperature of the reactants, we are providing energy to them in the form of heat. So when the energy of the reactant molecules increases, the collision between those molecules increases, which increases the rate of reaction in turn. Actually, stirring also has the same effect. When we stir the reaction mixture, the collision between the reactant molecules increases and therefore the rate of reaction increases. The next important factor is the presence of catalyst. The presence of catalyst increases the rate of reaction because it provides an alternative pathway for the reaction to take place, which involves lower activation energy, has a smaller energy barrier. The last important factor is the presence of light. There are certain reactants which get influenced by light, which are very sensitive to light. For example, the halides of silver. But otherwise, in general, we can say that higher the intensity of the light, higher is the energy absorbed by the reactant molecules and higher will be the collision between them, which will increase the rate of the reaction. The next important term is the rate law. Rate law can be defined as the mathematical expression of the relationship between the reaction rate and the molar concentration of one or more reactants. Suppose there is a general reaction, let's consider, in which X moles of A react with Y moles of B to form one or more products. Now the rate of this reaction will be proportional to the concentration of the reactants. Let's say it's proportional to A raised to M and B raised to N. Now when we write rate is equal to A raised to M and B raised to N, we introduce a proportionality constant, that is K. This K is known as the rate constant. Now there is one important thing to keep in mind, that M and N may or may not be equal to X and Y. because M and N are experimentally determined quantities. Next important term is the order of reaction. Order of reaction can be defined as the sum of the exponents to which the concentration terms are raised in the rate equation or rate law of the reaction. For example, we just derived this rate equation in which rate, that is dx upon dt, is equal to k a raised to m b raised to n. Now the order of reaction with respect to the reactant A will be m, and the order of reaction with respect to the reactant B will be n, and the overall order of the reaction will be equal to m plus n. This property, that is the order of reaction, is an experimental property. It can assume any value. It can be fraction, zero, or any whole number. And it may also change with change in the conditions of the reaction.